In this experiment, we are going to simulate the stop and wait protocol using Cisco Packet Tracer. The objective of this experiment is to understand how stop and wait works, how a sender transmits one frame at a time, how it waits for an acknowledgement, and how the next frame is transmitted only after successful acknowledgement. We will also observe the movement of packets through switches and a router using simulation mode. Let us first look at the network topology. We have two separate LANs. On the left side, we have two PCs, PC0 and PC1, connected to switch 0. On the right side, we have two PCs, PC2 and PC3, connected to switch 1. The two switches are connected through router 0. PC0 and PC1 belong to the first network, 192.168.0 with subnet mask 255.255.0. PC2 and PC3 belong to the second network, 192.168.2.0 with the same subnet mask. The router acts as the connection between these two different networks. PC0 is configured with IP address 192.168.1.2 and default gateway 192.168.1.1. PC1 is configured with IP address 192.168.1.3 and the same default gateway. On the right side, PC2 has IP address 192.168.2.2 and PC3 has IP address 192.168.2.3. Their default gateway is 192.168.2.1. Router 0 has two interfaces. Gigabit Ethernet 0HEL0 is configured with IP address 192.168.1.1 and Gigabit Ethernet 01 is configured with IP address 192.168.2.1. Both interfaces are enabled using the no shutdown command, but we switch from real-time mode to simulation mode. Simulation mode allows us to observe the movement of packets step by step through the network. At the bottom right, we select simulation. We use the Add Complex PDU option. The Complex PDU tool is represented by the open envelope icon in the right side toolbar. For the first demonstration, we select PC0 as the source and PC2 as the destination. The destination IP address is 192.168.2.2. We select a one-shot transmission and create the PDU. An envelope now appears on PC0, indicating that a packet is ready to be transmitted. We click Capture and Forward to move the packet step by step. First, the packet leaves PC0 and reaches switch 0. The switch examines the destination information and forwards the packet toward the router. The packet then reaches router 0. Since PC2 belongs to a different IP network, the router performs layer 3 forwarding and sends the packet toward the second network. The packet travels from router 0 to switch 1 and finally reaches PC2. We can pause at each step and open the PDU information window. This allows us to observe the OSI model, source and destination addresses, and the processing of the packet at each device. After PC2 receives the ICMP echo request, an ICMP echo reply is generated and travels back from PC2 to PC0 through switch 1, router 0, and switch 0. At this point, we can relate the packet exchange to the stop and wait concept. Conceptually, we can consider the first data transmission as frame 0. The sender transmits frame 0 and waits for an acknowledgement before sending the next frame. So the basic sequence is frame 0 is sent, the sender waits, the acknowledgement is received, and only then can the next frame be transmitted. Now we create the second complex PDU from PC0 to PC2. We again select PC0 as the source and PC2 as the destination and create a one-shot PDU. We then use capture and forward to observe its movement through the network. Conceptually, this second transmission can be considered frame 1. After frame 1 is successfully received and the acknowledgement is obtained, the sender is ready to transmit the next frame. The sequence number pattern in stop and wait can therefore be represented as 0, 1, 0, 1, 0, 1, and so on. These sequence numbers are used to distinguish new frames from duplicate frames. For example, suppose frame 0 is transmitted successfully, but its acknowledgement is lost. The sender does not know that the receiver has already received frame 0. After the timeout period, the sender retransmits frame 0. The receiver examines the sequence number. Since it has already received frame 0, it identifies the retransmission as a duplicate and does not deliver the same data twice. It sends the acknowledgement again. This is an important purpose of sequence numbers in stop and wait RQ. The basic operation can therefore be summarized as follows. The sender sends one frame, waits for an acknowledgement, and if the acknowledgement arrives, it sends the next frame. If the acknowledgement does not arrive before the timeout, the sender retransmits the same frame path. The result of this experiment is that we successfully demonstrated the stop and wait communication concept using Cisco Packet Tracer, observed packet movement through switches and a router in simulation mode, and understood the concepts of sequence numbers, acknowledgement, waiting, timeout, and retransmission. This completes the stop and wait protocol simulation experiment using Cisco Packet Tracer.